Today we'll be working on the following problem. Let X and mu be a measure space. P is between 1 and infinity. And we have a sequence of measurable function f sub n, which are in LP space. And also f is in LP space. F sub n converges to f almost everywhere as n goes to infinity. And also the LP norm of f sub n converges to the LP norm of f as n goes to infinity. We want to prove that the LP norm of the difference between f sub n and f converges to 0 as n goes to infinity. Pause the video if you want to work on this problem by yourself. Okay, let's prove this. First, we just want to show a very simple inequality, which we will be using to prove the conclusion, which is the inequality says like for all AB in R and P greater or equal than 1, we want to find A minus B, the absolute value raised to power P. Power P. This is less or equal than, of course, from the triangle inequality, this is less or equal than the absolute value of A plus the absolute value of B raised to the power of P, right? And now this is actually less or equal than, if the absolute value of A is greater or equal than absolute value of B, then A plus B less or equal than 2 times the absolute value of A, and then raised to the power of P. And then if this is less than this, the absolute value of A less than the absolute value of B, then this become at most 2 times B to the power of P, right? So 2 cases. But then in either of the cases, like this is of course less or equal than 2 times A absolute value of A raised to power P plus 2 times B to the power of P, right? This 2 to the P, and then 2 to the P power times this, right? So now we can use this apply to, we want to estimate f sub n minus f, the absolute value raised to P's power. This is less or equal than 2 to the power of P times the absolute value of Fn to the power of P plus F absolute F to the power of P, right? So from this we have this. Now we can define another sequence, which is H sub n. This defined to be the difference between these two, which is 2 to the power of P, F sub n, P plus to the P, and then minus the difference, take absolute value raised to the power of P. So from this inequality, we know this H sub n is greater than or equal to 0, right? It's positive. And now also from the assumption, f sub n converges to f almost everywhere. So if we take, so we let n goes to infinity, so which means, so that's H sub n goes to what? So f sub n goes to f. This is f, 2 to the power of P plus 1 times the absolute value of f raised to the power of P. This almost everywhere, right? The function. So now if we write this, so if we now take an integral, so if we take integral about this, to the right hand side 2 to the p plus 1, and then to the p, take an integral over x. This because h sub n goes to this almost everywhere, so this is the limit n goes to infinity h of n d mu, right? Now we can apply Fatal lemma. By Fato's lemma, this is less or equal than what? The limit inf n goes to infinity, and then this integral h sub n over x, right? And now we can write down the format, which is the limit inf. And then what is this hn? By definition, it is 2 to the power of p, f, the absolute value raised to the power of p, and then plus f to the power of p d mu over x. This, and then minus the integral of the absolute value of f sub n minus f raised to power p, right? So now by assumption, we know the assumption is like the LP norm of f sub n also goes to LP norm of f as n goes to infinity. So by the LP norm is just so for this one, for this, and then take the root of 1 over p, right? So for this one, this goes to, when we take the limit, this goes to 2 to the p power of p, and this goes to f p, and then the same over here, right? And then so because this is minus, and then when we use the lower limit inf, this becomes limit sup and goes to infinity, and then what is this? This is 2 to the power p plus 1 times the integral. And then minus the limit supremum and goes to infinity, and this integral. Right? What do we have? We have this equal to this, right? 2 to the power of p plus 1, and then the integral of the absolute value of f to the power of p, and then minus this, right? This less or equal than this, and then this tells us the limit n goes to infinity must be 0. Right? Because this positive, this number less or equal than the same thing minus So this has to be 0. So that is the LP norm, right? Because you just take to the power of 1 over p. The LP norm of the difference goes converges to 0 as n goes to infinity. That's it.